In the name of Almighty Allah, the most gracious, the most merciful. As Muhammad, peace be upon him, narrated, if anyone travels on a road in search of knowledge, Almighty Allah will cause him to travel on one of the roads of paradise. Hello everyone, this is Dr. Tariq Masood. Thank you very much for watching my videos and your wonderful support to make this channel a grand success. We are a partner of family. Please share and subscribe our channel if you haven't done so far. We as a team can work together to convert challenges into opportunities and opportunity into success stories. These success stories can be monetized into value addition in the world by large. Thank you very much for your precious time. Today I'm going to discuss my lecture number 34. Oil and gas productions, exploration, production, upstream, midstream, refining, petrochemical differentiated performance, enabling profit optimization, lecture number 34. Before my lecture, I used to read a Quranic verse. Qala Rabbi Shrahli Sadri wa Yassarli Amri Wahlal Uqdatam min lisani Yafqahu Qawli Allahumma Rabbi Zidni Ilma. O my Lord, open my chest and ease my task for me, and loose a knot from my tongue that they may understand my sayings. Allahumma Rabbi Zidni Ilma, O Allah, advance me in my knowledge and a true understanding. Thank you very much. Please send me your input. I have also provided my WhatsApp number and email address end of my presentation. Okay, oil and gas production. Introduction, we have already discussed. Facilities and processes management system, reservoir and wellhead management systems, upstream facilities and management systems, midstream facilities, refining facilities, petrochemicals, utility systems, unconventional, conventional resources and environment effects. What is the ultimate goal? Shaping the clean and sustainable global energy delivery. Plan to deliver more than 300 lectures next couple of years. Okay, oil and gas productions, Digitality System, lecture number 34. What we're going to discuss today, ESD and PhD, emergency shutdown system and a process shutdown system. Okay, key takeaway points from lecture number 34. Emergency and process shutdown system, fire and gas detection systems. Okay, ESD and PhD. The emergency shutdown and a process shutdown systems will take action when the process goes into malfunction or dangerous mode of state. For this purpose, the system maintains four sets of limits for a process value. First is low, LL, low, small 1L, high and high. L and H are a process warning limits, which alerts to process disturbances. LL and HH are alarm conditions and detect that the process is operating out of range and there is a chance of undesired events and malfunctions. Separate transmitters are provided for safety system. One example in the LTLL, level transmitter low or LSLL, level switch low alarm for the oil level when this condition is triggered. Okay, ESD and PhD system. There is an example that LTLL, level transmitter low or LSLL, level switch low alarm for the oil level. When this condition is triggered, there is a risk of a blow-by, which means a gas leaks out of oil output and causes high pressure in the next separation stage or other following process equipment such as desalter. The transmitters are preferred over switches because of better diagnostic capabilities. Okay, emergency shutdown actions are defined in a cause and effect chart based on hazard of the process. This study identifies a possible malfunction and how they should be handled. If you can see the schematic, we find a possible shutdown actions at an oil and gas facilities, the primary response is to isolate and depressurize. In this case, the typical action would be to close the inlet and outlet sections valves, that is EV015320 and EV010820 and EV010220 in the diagram, as you can see in the schematic, and open the blow down valves EV011420. This will isolate the malfunction unit and reduce pressure by flaring of the gas. Okay, ESD and PSD system. If you can see in the schematics or in the cause and effect chart, we have a possible emergency responses. Whenever the events are classified on a scale where 0 to 5 where a full abandoned a platform, a facility shutdown. So ESD 0 as the highest level mean a complete shutdown and evacuation of the facility. The next level ESD1, ESD2 defines emergency complete shutdown. The lower levels, for example PSD3, PSD4 and PSD5 represent a single equipment or process section shutdown. Okay. A split between APS, ESD and PSD is done in large installation because of most signals are PSD, process shutdown, and can be handled with less stick requirement. These actions are handled by the emergency shutdown system ESD and process shutdown system PSD according to functional safety requirement and standards. Thus, a typical ESD functions might require a SIL 3 or even SIL 4 levels, while PSD loops could be SIL 2 or SIL 3. Smaller ESD systems, for example on wellhead platform, can be hydraulic or head voids non-program systems. Okay, fire and gas detection system. The fire and gas system is not generally related to any particular process. Instead, it divides into fire areas by geographical location. Each fire area should be designed to be self-contained in that it should detect the fired gas by several types of sensor and control of fire protection and firefighting devices to contain and fight fire within the fire area. In the event of fire, the area will be partially shut off through closures of ventilation fire dampers. A fire area protection data sheet typically shows what detection exists for each fire area and which fire protection action should be taken in case of an incident. The types and number of detection, protection and fighting devices depends on the type of equipment and size of the fire area and will vary for different process area. For example, electrical rooms and accommodation rooms, etc. Okay, from next slide we will discuss the fire detection system. Okay, fire and gas system. First, gas detections. Combustible and toxic gas, electrocatalytic or optical IR detector. Number 2, flame detectors, ultraviolet, UV or infrared IR optical detectors are used. Fire detections, heat and onic smoke detectors, and number 4 is manual push buttons are used. Okay, firefighting and protection system. Firefighting and protection system. First, gas-based firefighting such as CO2. Second is a foam-based firefighting system. Number 3, water-based firefighting system, for example, sprinklers, mist water supply, and deluge system. Okay. Number 4 is a protection interface to emergency shutdown and HVAC fire damping systems. Number 5, warning and escape, PA system, beacons, lights, fire doors, and dampers releases. Okay, fire and gas system. A separate package related to fire and gas is the diesel or electrical driven fire water pumps for the sprinkler and deluge ringman. For fire detection, coincidence and logic are often used to identify false alarms. In such schemes, several detectors in the same area are required to detect a fire condition or gas leakage for automatic reaction. This will include a different detections principle, for example, fire but not welding or lightning strike. Action is controlled by a fire and gas system (FNG). Like ESD system (FNG), action is specified in a cause and action chart called the fire area protection data sheet. If you can see on my schematic, I have demonstrated the chart shows all detectors and fire protection system in a fire area and how the system will operate. The FNG system often provides supervisory functions either in the FNG or in the information management system IMS to handle such tasks efficiently. For maintenance, calibration or replacement and hot works permit, for example welding, such actions may require that one or more fire and gas detectors or systems are overridden or bypassed. Specific work procedures should be enforced, such as placing fire guards on duty to make sure all devices are re-enabled when the work permits expire or work is completed. Okay, conclusion. Today we have discussed ESD and PhD system, emergency shutdown system, and process shutdown system. Fire and gas system. Okay, next topic, we are going to discuss control and safety configuration. Okay, references. So, Qatar Petroleum, Doha, Qatar, Oil and Gas Development Corporation Limited, Pakistan, OGDC, Pakistan, World Energy Outlook 2030, US Geological Survey, US Department of Energy, Schlumberger's Oilfield Glossary, International Energy Agency IEA, Wikipedia, Oklahoma State Margin Well Commission Pampers Manual, State Oil Fact Sheets Norway, NOR6 Standards Norway, The Story of Oil in Pennsylvania, Air Liquid Gas Encyclopedia, Natural Gas from Wellhead to Burner Tip. Okay, together everyone achieve more. Please do not hesitate to send me your precious input and comments at t.masood.dr@path.edu. You can also give me your input through my WhatsApp number as I provided. Please stay at home, inspired and blessed. Thank you very much for your precious time.